Okay, good morning. Until others join, we will start. Can you all hear me?
Yes, sir.
Okay. What we are going to do today is to basically do an exercise, design your database, a simple one. And then you can further develop it and submit as an assignment. So you will be doing two things. One is the preparation of the schema, which you can do using the Excel sheet. Second part is the actual geodatabase that you are going to create. So when you create a geodatabase, you don't have to have data in your feature classes. Feature classes can be just the names and the tables. You don't need the data. But if you want to add arbitrary data, that is fine. So the steps, first the simple geodatabase containing several feature classes. And after that, we will introduce a little bit more advanced features to this database, and we alter the feature classes and have it. What we can do is the first one, we will have, you know that feature geodatabase can contain feature data sets. Feature data set is just a container, so you can have any number of feature data sets. First feature data set will have individual feature classes and about 4, and then you will join them into 1 or 2 plus tables in the second feature data set. Now, so we will create 2 feature data sets and populate the 2 feature data sets with feature classes. And the tables, normally the feature data set does not allow you to add tables to. You can have your tables in the common area outside the feature data set, but within the geodatabase. So I previously mentioned the type of data that we are going to include. Now, if you want to add data to your feature class, you can do it from ArcMap. After creating the feature classes, you can load them into ArcMap. And then using Google Earth, you can add, I will show you how to add Google Earth also to your desktop. Google Earth within, you access Google Earth from ArcMap. Then you can basically use it with your data. As you know, Google Earth has WGS 84 coordinate system. Now, when you are working with the Google Earth from ArcMap, the coordinate system of the Google Earth, the native coordinate system of Google image, will be automatically transformed into the whatever coordinate system that you are using in your ArcMap. There are two ways to I will explain it later. That means that you can basically get an area of Sri Lanka and digitize using the Sri Lankan coordinate system. So that advantage is there with the Google images. Some limitations are there. If you go to Google Earth, for example, you have historical images, and you have basically a control on what year, to a large extent, what year data that you are interested in. All the available data for your region will be shown when you enable historical images. Unfortunately, in ArcMap or ArcGIS Pro, we only have access to one time step, one image, basically. We don't have access to historical images. Now, the image that we have is usually up to about 3 years old. So that doesn't affect most of the work that we do. So 3 years is basically okay. But if you need contemporary images, images of this year, for example, then you have to download from Google Earth the most recent image, and then you need to georeference it, which you can do in ArcMap. The georeferencing Google Images is a process that you can activate within ArcMap, provided you mark certain control points on the Google image. Or you can when you save the image, you can have the grid place over it. And what you need is a minimum of 4 control points. But if you have more, it is better, because Google image will have distortions due to the relief and the earth curvature and so on. Therefore, you might need a lot more control points. But if you are using a very small area, that might not be a big issue. Right. To start work for today, I start with an Excel sheet. I mentioned that when you design geodatabase, best thing is to have the documentation. You need to define a theme, the kind of data that you need, and then document it. So the things that you have to document, you have the geodatabase first, so it should have a name, and you may decide to have feature data sets, in which case each feature data set, if you are going to have multiple feature data set, each data set should have or would have a series of feature classes. Each one has a series of feature classes. Each feature data set has to have a coordinate system defined. So each one has a predefined coordinate system. So therefore, when you add data to a feature data set, make sure that your data is in that coordinate system. Okay, so in the document, what do we need in the documentation? This helps actually you to maintain your geodatabase in a systematic way, so you don't do ad hoc decisions while you are designing it. So the first step, therefore, is to have all the feature classes in each of the feature data sets listed out. So page 1 is that. So the entire GDB is recorded in the first worksheet of the Excel sheet. Of course, you have to remember this is not going to be part of the geodatabase. It has nothing to do with the geodatabase. This is just for you to have a sketch of what your database is going to be. So you adhere to this when you are creating your geodatabase. This is to prevent you making mistakes when you are creating your database and also populating it. So if you look at this worksheet, you see the name, the first page, it has the name of the geodatabase. The geodatabase name, in this case, in this example, is branch locator. This may be, let's say, a bank. Bank has so many branches. So this database is to map all these branches and some other important information of these branches. So branch locator. The next thing is to identify a feature data set. Feature data set name. Now, it is always better that you have your thematic layers in a feature data set or in many feature data sets. You may be mapping the branches of banks. You may be mapping grocery stores. You may be mapping all the other things, all other different things. In which case, you might need different feature data sets in order for you to. This is not essential for ArcGIS, but this is for you to make life easier, keep the database neat. So this example has one feature data set, which is called branch location. The name of the database is branch locator, branch location is the feature data set. Now, you are not bound by any of these names. They are entirely up to you. The designer can come up with any kind of names. There are no default names. They are all of them are up to the designer of the geodatabase. Now, feature data set is now defined. And then feature data set is populated with data. The data that is admissible to feature data set is feature class. So we can have several feature classes. Now, feature classes, there are three types of feature classes: point, polygon, line. So these are the three geometric types that we have. So the data type is an important field in this table. Then feature class name. This is the name that you are giving, that you are going to give to your feature class. And the feature class name. Okay. Feature class name, we are location of branches which have been already established. Now, this is the existing bank branches. So a bank branch location is usually a point. Therefore, the feature type is point, or geometry is point in this case. Branch area. The area, some geographic area within which your branch is located. It may be Candy MC or some such thing. So the current branch located within a certain area. Now, area has to be a polygon. This is the area around the branch. Area covered by each branch which have been already established. Now, this is important. At some stage, if you want to expand the network, you go for areas that are most suitable for a new branch. So you want to know which areas are covered by the bank, which areas are not covered by the bank. But there are other criteria that you can use. For example, in a small area, if your clients, you have unmanageable number of customers for one branch, you might decide to start another branch in the same locality, not at the same location. Maybe one in the town area, one in the Candy city centers, like some banks do. For example, Bank of Ceylon, Commercial Bank, People's Bank have city branches as well as city center branches. City center branches are for the customers who are visiting these places. So easy access to the branch, that is the idea. The polygon is basically the service area. Therefore, service area has to be a polygon. Then we can bring in administrative divisions if you want, one or many, GN, DS, district, and so on, if you need. GN division is the smallest administrative division. So the division can be included in the database. So that division would be a polygon. Land use of the area, this is not terribly important for a banking system. You might want to have population data and things like that, income levels of the population, whatever economic data that you have. Land use is not terribly important. This is just an example. Then road network is very important because the branch has to have good access. What I described is relating to bank. But the exercise we are going to do is even simpler. It's the one I described last week, but we will get into that. I'm just giving you another example where more details can be shown to you. So that's the first page. And if you, feature class, feature dataset name, location, branch location. If you want to have many feature datasets, in your Excel sheet, you can have other feature datasets as well. So this is just to separate one feature set from the others. You repeat what we did in the first one, and when you come to the end of it, if you want another one for another type of data, you can have another. So all the feature datasets and the feature classes within them are listed in this page. Okay, so this is the first page of your schema. Then we go to the second page, tables. So this is actually what I'm describing here is very common for any geodatabase. Therefore, don't worry about this specific example. It is just to show you how these things are done. What we have here is tables. Okay, each of the feature classes. Okay, each feature class has an attribute table attached to it. That is called in relation to feature classes, also in relation to shape files or shape files. You have a feature attribute table attached to it. It is within the data set. Now, this attribute table can be accessed directly when you load your feature class to ArcMap. So it is transparent to you that you always see both together. Of course, you are not limited by this attribute table that you have attached to the feature class. Suppose you have a map of administrative divisions of Sri Lanka. Let's say the GN map of Sri Lanka, that the survey department provide you a GN map of Sri Lanka. There are 14,000 plus GN divisions. Now, this map can be the spatial component of many types of data. Okay, many types of data. And all these data types don't have to be in our attribute table. Because when you have thousands of attributes in your attribute table, loading the data becomes very slow. Therefore, you don't want to have all these things in the feature class. So what do? We can have a separate set of tables for each thematic area. For example, demography by administrative divisions. Let's say GN division. So demography by GN divisions, we have a separate table. And let's say some communicable disease like corona, the corona data can go into a table, and we can add table into the geodatabase. Similarly, economic data, social data, education data, whatever data that you gather can be collected, can be presented as tables, and those tables can be stored in the geodatabase. Only thing is that the feature data sets don't allow you to have tables within it. So these tables have to be kept separately in the common area. So you can access the data that way. Because a feature data set is a geometric component. Geometric component. When you have data without geometry, that cannot be accommodated in the. That's the whole idea. Now let's look at the table. Now, when you come to the attribute table or an independent table, now we are talking about two types of tables. One attribute table. Whenever I say attribute table, that is a table attached to a feature class. If I just say table, it would be an independent table that is kept in the common area. Now, so both types of tables are listed in this page, all the tables. Now we have feature classes, branch network, branches, branch area, GN division, land use. In this example, I put land use also, road data, okay, transport network. Now, those are the feature classes that I have. And for each feature class has a table. So each table has multiple fields or attributes, multiple fields. Attribute, another name for attribute is a field. So you can have number of fields within the table. That means the columns with data. So the field names are listed under feature class. Okay, field attribute field name. Then field type. This is basically the data type. So in this case, you have current branch. This is basically everything that the feature class contains. Branch code is there. Shape is the geometric part. We can't do anything with it in terms of tables, but it is automatically generated. It is there. Branch name. These are things that we add. Branch name we add. It is text. branch grade, it is also text. Bank transactions, that is data, short integer. Credit request, integer. Distance to nearest branch, it is either integer, or you can even have real, but to the last meter, you don't need the information. You might say it is 2 kilometers from here or whatever. But if you want, you can have the exact distance also. Alias is actually, this is used, the attribute names are usually abbreviations. In order to save space, we don't have lengthy names. We don't give lengthy names for attributes. But we might want to see lengthy names when we visualize data. So in which case, we can define aliases. These are not compulsory. You can define an alias for a feature class, for an attribute. So this is repeated, and this record is for the current branch network. That is the feature class. The second feature class will have fewer attribute names. GN division class will have a little bit more columns, fields, more data. So like that, you can have any number of so each data layer you have this. In this example, I have listed only the tables that are within the feature classes. That means attribute tables. If I had independent tables, I could have added them also as independent table. Okay, so table name, and then you have normally table name is the same as the feature class name if there is a feature class. Okay, so the table has the same name. Current branch is the feature class and also the name of the table. That is why the table under table name we have the layer names. Okay, but if there are independent tables, they can have their own names. So that's something that you need to remember. Alias. Okay. Now the next one is the next column is null values. Null value means can we leave a particular cell empty? Let's say Peradeniya branch of the commercial bank, Peradeniya branch. Okay, commercial bank, Peradeniya branch. When we are adding data to it, can we leave a particular column empty? Now let me see. Branch name we might know. Branch grade at the point of data entry. Let's say at the point of designing this data sheet. Suppose we don't know. At the time of data entry, we don't know. We postpone it to a later date. So we will add that data later. In which case, if you say no to null value, the data cell cannot be kept empty. We have to enter something in that cell of the table. Okay. One way out of this is when you digitize Peradeniya Commercial Bank branch, for example, and go to the attribute table, and then we have to enter something there. You can't leave it null. In which case we can say not known, for example. It's a text variable. You can say not known. But if you say null values are yes, you can leave it blank. If you say null values feel no, then you have to enter something there. So that you can determine. This is in order to prevent having empty cells in your database. That if you consider all these data types essential, then of course you have to first find out what the branch code is, and then you enter it at the point of creating the database, populating the feature class. The next, certain attributes may have default values. Certain attributes may have default value, in which case you can define the default value. You do this when you are creating actually a real feature class. For this form, it doesn't matter. This form is helping us to create the feature class in the database. Then we have three other things. Let's say that is the domain. Domain is the permissible values in a particular cell. Permissible values. So domain can be either character field, string field, in which case we use it as a coded domain. Coded domain. We type a code, and against that we give the text name, long name. Second one is subtype. Subtype is when you compile, digitize some geographic features, see if you can subdivide this into different feature types. Last week I gave you an example. The transport network, we have freeways. It can be one category of road network. So freeways are there. Then railways are another category, another subgroup within the transport network. And then the road network also, the rest of the road network is also subdivided into road. The ownership of these roads fall into RDA roads, and then we have Pradeshiya Sabha roads. We can use those subgroups, or we can go by the road class, A, B, C, that kind of, or main road, secondary road, jeep track, footpath, that kind of thing. Oh, and in addition, you can even have trails. Trails are very important in tourism development. There may be nature trails in certain areas. So those things, if you have mapped, those things can be also added. So in order to group the features in a feature class, we can use this facility subtype. So these are things that, so in order to, when we are creating our feature classes, to remind us what should be the nature of the data that we are entering. So to keep tag of what we are doing, we have this guide to help you. This is not a part of your geodatabase. This is only to assist you in correctly preparing, designing your geodatabase. That's all. After designing, you can put it aside and you don't need it anymore. So okay, that's the second page, which gives the tables and some description of these tables. I mentioned domains and subtypes. Let's go to the domains field. Some of the one thing that you have to remember, domain is something that you have to have defined for the entire database. That means multiple data layers can go in the same domain. And therefore, it is going to be in the common area of the database. So we define for the database. So what can we have in our domain? So in the previous one, in the tables, we have listed certain attributes having domains or subtypes. So domain field, we can define domains either as coded values or range domain. Now, coded values means we can have numbers, short integer numbers, for example, as codes, and then type the text value. And this code will be entered into the database. So the code would be in the feature class, and the long name will be there. What it will do is, when we are entering data, we can basically have this domain list. From that, we can select the value. That is the whole purpose of having a domain. Coded domain. And then the range domain doesn't allow you to select a value from an existing list. What it does is, it will define the permissible range. So outside this range, you can't enter a value. For example, in the first one, branch code has a range domain. If the data type is short integer, range domain, and the codes we have from 0 to 3000. But inadvertently, when you are typing 3000, if you type an extra zero by mistake, then the database will not accept that value. That it will give an error value. That way, the range domain as well as coded value domain help you to maintain the integrity of your data. So the data accuracy can be maintained that way. The coded values also, so you have a set of values, only those values can be entered into the relevant cell of the table. In fact, you can select this whole list is available, so you can select the list. In the range value, there is no list. Whatever the number you type, it will check against the defined range. And if it is outside that range, lower or higher, then that number will not be accepted. That's all. So this is a method used for to maintain data integrity. So we can have that built into the database as well. Subtypes I already described. Subtypes here is there are 3 grades for the bank. So all the branches belong to one of the 3 grades. Most branches, suppose most branches are 3, and fewer have lower grades. So what does that mean? The 3 is the most commonly occurring number. Therefore, we can declare it as a default value. Now, default values can be changed. Let's say a particular branch, which is grade 3, no change is necessary, data is already entered. Then you go to another branch, which is not grade 3, grade 2. So you change, but automatically it will get 3, but you can change it to 2. That's the advantage. So this also makes data entry much easier and also maintains data integrity. Relationship class I'm not going to describe now. That is necessary when you are working with tables. Tables that are not attached to a feature class. So you want to use external tables for different kinds of analysis together with the feature class. That means you will you can use this facility for that. Okay. Right. Now I am now going to talk about the database, the exercise that we are going to do today. Okay. Let me work with your database from scratch. Now, for this exercise, what we are doing is creating few data layers. One is diners, the people who go and the customers of places where food and drinks served. Then you have different kinds of establishments like cafes, restaurants, bars and lounges. Those are the places where you can sit down and have some food or drinks. And yeah, bars and lounges. Yeah, okay. So there are 4 types of establishments are available for serving food and drinks. Now, there are 3 types of establishments. Maybe 4 types, but the 4th type is a combined thing, bars and lounges. We introduce it deliberately for some purpose. I will explain to you. So you have diners as a separate group. Now, diners diners are the people who go and patronize these places. Now, why they are important is they are the ones who are going to write reviews about these places, the quality of the place. Like the internet websites, this kind of reviews are usually available for restaurants, hotels, and so on. So that's the idea. Now, in this case, all of them are listed here as feature classes or shapefiles. Okay, before coming to a database, it would be a shapefile. There is a slight problem with the owner, the diner, because diners are people who come from different places. Their location, is it important to us? It's a question. If you keep the location, we have to have a separate shapefile for them. They are only evaluating the quality of the establishment. If you think their location is not important, then it doesn't have to be a feature class or a shapefile. So we keep it provisionally as a shapefile. At this stage, it is a shapefile. So we have 4 shapefiles or feature classes. Now, if you think of creating these as feature classes, we have to have database, geodatabase, or some other database. We need a database. Now, in this case, we are going to create a feature geodatabase. Now, how do we do that? A lot of things we do using ArcMap, but if you want to create something new, a table, feature class, shapefile, or something like that, we have to use either the independent program called ARC Catalog, which is available in this. I started in this window. It's called ARC Catalog. It's a separate program. You can run it separate. So you can use that. Alternatively, there is a simpler option within ArcMap desktop, which is called Catalog. The previous one is the full program is called ARC Catalog. Here we have Catalog. So Catalog is this yellow button in your ribbon. So click that. You get simply like this works like a browser, but there are additional features also. Now, when you click on a Windows browser, you basically get similar list of folders and list of folders and files. Now, in order to create a feature class or geodatabase feature class or geodatabase, we can have to go to the file system. Now, I'm going to use a common area workspace. It is an existing folder. If you want to create a new folder, you can do that also. All you have to do is inside this window, right click, new, you get these options. Folder. Inside this folder, you can create a folder. File geodatabase, personal geodatabase, database connection, and so on. Shapefile, DBase table. If you want to create tables, you can either create tables using DBase tables, or alternatively you can use the Excel tables. With Excel, you can save it as a CVS table or something, and then incorporate into this. Right. Okay. Now what we are going to do is, in the workspace folder, I'm going to create a geodatabase. Right click on the folder name, new, I'm going to create a file geodatabase. And I'm going to call it, this is the default name. Default name is always new file geodatabase. If you already have one, it will be given a different number. I will call this design temp your database. Temp your database. Okay, now I created database. That's simple. It is like creating a folder. So you can create a geodatabase. Remember, when you create one, you have these icons. So you can clearly, if you are using catalog, each geodatabase will appear with this icon. But if you are using the Windows browser, it will simply appear like a folder. Okay, so that's the difference. So in order to view it correctly, you have to use the catalog, OAuth catalog. Right now, I have created a geodatabase. Now, this geodatabase is empty. It can be used to store any kind of data, any kind of spatial data, or tables, or images, networks, and all kinds of things can be stored. Now, in our exercise that we are going to do, we are going to create, let's create a feature data set also inside this feature data set. Again, right click on the geodatabase. And right click, then new. In that, there are things that the top 3 things that we can create. We can create a feature data set, feature class, a table. Okay, 3 things we can create. And then we also have relationship class can be created, mosaics can be created, and there are other options. But for now, we want to create a feature data set. That's a container of data, feature data set. New feature data set, okay? New feature data set that we want to, feature data set, okay. Click. First thing that we have to do is to give a name. What our focus is this dining location. Let's call it dining places. Space is not allowed in your database. Okay, and there are few steps that you have to follow when you are creating a new feature data set. Okay, the first is the name. Next. Next thing is it wants to know what coordinate system that you want to assign. You can basically assign any of the projected or geographic coordinate systems that are available as standard coordinate systems in the world. Or you can define your own system. When you define your own system, then you have all kinds of other complications. But let's say we are selecting a coordinate system from an existing. Now we are in Sri Lanka. We have 2 projected coordinate systems, older or new. I'm going to use the Kandavala, or you can use SLD 99, whichever you want. This Kandavala. selected color. Next. Okay, next. Next is choose the coordinate system and system that will be used for Z values. Z values are the elevation values, not elevation values, the third dimension. Elevation can be one of them. We are not going to, we are going to create two-dimensional feature classes. Therefore, we don't need to define that. Next. This is the XY tolerance, the level of accuracy that we want to maintain. Standard is 0.001 of a meter. That is more than enough. So we keep those values and say finish. Okay, you can see it is now listed, dining places listed in this feature class. Now, it doesn't have data layers. Now I'm going to create 4 data layers. 4 data layers. The document that I provided to you has all these things, but I'm demonstrating the use of these things. Okay, I'm still in catalog, right? I'm still in catalog. I have not gone out of that. So that means I'm using catalog to do all this. I click on right click. Remember, it's not left click, it's right click. That gives me options. So this time, within feature data set, new, I am not prompted to create a feature data set. That option is not available. That is, you can't have another feature data set within the feature. It's not nested. Feature data sets are not nested. Feature data sets have to stay in the home directory of the folder, home directory of the database, geodatabase. So if you have 10 feature data sets, all 10 have to be in the root of the geodatabase. So they are not within, they are not different data sets are not nested. So I have options, among which the option that I want is feature class. I'm going to create the feature class. So this is the creation of feature classes. First feature class that I'm going to create is diners. Diners. If I want to visualize this feature layer in a different name, I can type alias in this row. If I am happy with diners, I can keep it. So I don't have to enter anything. I don't need the alias for this. It is up to you. You can decide what you want. Then by default, this is very important. After giving a name, make sure you define the data type here purposely, intentionally. You don't allow the default to proceed. If you proceed with the default, you invariably end up with a data layer which is polygon. Okay, whether you want it or not, your default is a polygon. Therefore, I have to change it to points. All my layers are points. Therefore, I make it a point. Point features. Geometric properties you don't have to worry about. Okay, two things I did in this window: gave a name and define the feature type. Feature type, always you have to do that for a feature class: point, line, polygon. Don't use the default unless your data, the data that you are going to digitize, match with the default type. Next, specify the database storage configuration. We are not going to use this facility, and therefore we use the default. Now we get the feature class with two attributes. Both attributes are generated by the system. Okay, system generated attributes of the attribute table. Now I am going to add three attributes: name of the diner, geometry, the data type is text. Okay. Rating, short integer. Here we enter a number from 1 to 10. We enter a number. No, we enter a number, and that number will appear as a category. So I will explain that. Rating. That's all. Nothing else I want to add. So I have the name of the diner, rating that diner is giving, and shape is the integer, shape is the geometry. So data type is geometry here. Object ID is automatically created for each row of the table is given a unique number. That is, object ID is usually internal to the program. So we don't have to worry about these two variables. These are the two variables that attributes that we enter. Now, you might have heard me using terms like attribute, variable. What is the difference between attribute and a variable? Variable is something continuously varying. That would be elevation, rainfall, things like that. Then attributes actually, if you call all the data in a feature class as variables, some of them are not variables. For example, the names of people cannot be used, or places cannot be used, cannot be considered as variables. Variables have to be quantitative. They are continuously varying. Therefore, the term attribute is used in relation to GIS tabular data. Therefore, remember, attribute data includes both the variables and qualitative categorical data, continuous data as well as categorical data. So together we call them attributes. Rating is continuous within a range. Therefore, it has to be a number. A number can be so although it's not actually continuous, but it is varying from 1 to n. So we don't have decimal part. Therefore, we can consider it as short integer. If we want to include the decimal, we would say floating point numbers, okay, or real numbers, or whatever you want to call it. But in this, you have float. You have float for decimal numbers. Double means if you want to increase the precision, increase the number of decimal places, you will use double precision. Float is single precision. The number of decimal places are smaller. Double will have more decimal places. Then the date field, date is recorded differently. Therefore, we have data for date. There is a date field for recording dates. Blob, I don't know what that means. And then you have these three, I am not sure what it means. Okay, date field, text field. Text field can actually have numbers also. Number can be considered as a text. But only thing, if you consider a number as a text, you cannot use it for any calculation. That's the, so you have to be careful in designating it. Right, okay, I finished. Name. There's another thing that you have to pay concentration to, attention to. There's a little table below for the new values that you are entering. Name is the value that you added or I added. The alias, if I want, I can change it. I can say dynasty. Now, in this field, you are allowed to enter apostrophes as well, or have spaces, whatever. Because this is not the way the data is stored. This is just the way the data is displayed. Diner's name. Okay. For the name, person's name, do I need 50 characters to record that? So we can leave it as it is. Then up to 50 characters can be used as the name. Of course, in Sri Lanka, if you write full name of some people, it might need a 50 character. But if you're using, you don't need that kind of information. You can write somebody's name. In this case, you can remain anonymous also. You can write a nickname. So you can shorten this. So let's say 20. Even if you write your name with initials, 20 is enough. Rating. Remember I talked about null values. Now rating, do we allow null values? Let's say no. That means in the table, when you are editing, the value has to be entered. It's compulsory. Okay. Rating value has. That means everyone has to give a rating. What happens if somebody is not interested in doing this, participating in this? Then that person also have to, if he wants to enter his name into this thing, he will have to give a rating. Let's say we all want to rate. Then this field has to be populated with data. Finish. Okay, now diners is created. Now, second one, cafes. New feature class. Cafes. I don't need an alias. Not polygon point. This I don't have to worry about. Specify database storage configuration. No. Okay. Now see that in the previous table also we had these two fields already defined by the software. So that it is common to every feature layer that you. So this is the cafes. Okay, we have to enter the name. Text. 50 characters. Maybe 30 characters would be sufficient. There is a possibility of, if there is a website, not just have it website. Website of the place. That is text. That can have 50 characters. Websites usually are long. Rating. Rating has to be a number. In this case, short integer. That's all. That's the set of attributes that we want to finish. Third one, restaurants. Don't have to fill this. It's explanation. You don't need explanation. It's not a short name. Next. Next. Again, we come to the table. Here, we have to enter name, website, rating, okay, that's all. Name maybe 30 characters would be. Yeah, 3. We need another one. Fourth, bars and lounges. There are 2 categories lumped together. So this was done deliberately. Let's for this, it might help to define areas. I'm going to type bars without underscore, bars and lounges. Okay, bars and lounges. I want the database to show this as in this name rather than this. Underscores, I put underscores here because in naming feature classes or attributes, you can't have spaces. That's not polygon, it's again point. Go to the next table again. Okay. It has the name. Text. 30. Website. Rating. Short integer. Okay, now we have a geodatabase, file geodatabase called in this case, I called it temp geodatabase. Let me change the name. It didn't allow me to. Okay, they didn't allow me to change because my data layers are already automatically added to the. So that's the important thing here. If you use catalog, whatever data layers that you create will be automatically loaded into this ArcMap desktop. If you use Arc catalog, it doesn't happen because you have to purposely add the data to ArcMap. Okay. Now we created, at this stage, that's all we do. So we created 4 data layers. Okay. Now in these 4 data layers, a person goes to a restaurant or one of these places, and after dining in that place, he decides to write a report about the quality of this place, a review. And also he's going to rate the service of this place. So this is what the diner or the customer is doing. So that's the idea of this database. And for that, we have this 4. So the location of diner, if I am the diner, I will be there. And you have to enter your location as well. But this is unnecessary. We don't care where the person is located. Later on, we will correct that. We will improve this the method of entering data. Now, so none of these data layers have any data within it. So let me show you how to add now all these don't have data, but the coordinate system is defined. Okay. Now I'm going to add data. Sometimes I also find it difficult to add data, add the Google image to ArcMap because of the problems in the internet connection. But I hope it will work this time. So you have many options of a base map. Base map, you're adding a base map. The base map can be any of these things, OpenStreetLayer or imagery, terrain with labels, National Geographic map of the world, and so on. So I'm going to select the satellite image. Normally, it takes a while. So what this shows is I don't have data here. Therefore, it has recognized several things. One is the spheroid is Everest, Kandawala datum that is used, and most importantly, therefore the central meridian is going through Pidurusalagal. The second thing is that the projection it uses is the transverse Mercator is the standard projection that we use for our maps. So this is Google image projected using transverse Mercator projection. So this is our national grid. Now Sri Lanka is in the center of that. Let me see. This is for me to get the location. Right. So the database I created, it is empty, but this is something I did before. This is not empty. This has some little bit of data. It is the data that you can see that this is a bit slow. This slowness comes from two sources. One is the internet. The other is the software itself. ArcMap is 32-bit. That's one problem. The other problem is that it takes up a lot of computer memory by loading things that are not really essential for every single thing that you are doing. So it is not optional. By default, everything is loaded, those graphic files and the icons and all those things. Whereas ArcGIS Pro, which is more suited to more advanced computers, it is 64-bit, therefore it is faster. Secondly, it does not load all the files. It is made optional. So whenever you need something like the legend files and things like that, you can get them, add them to your project. Otherwise, it is not automatically loaded. That way, it is lighter. And the third thing is the ArcGIS Pro is able to work with new hardware. So that is another advantage. So anyway, so we are working with ArcMap and what the things that I have, I'm going to add the files I created. Workspace, not this one. Okay, I'm going to digitize all this. This is something that you can do by yourself. And what I'm going to show you is when you are working with files, with data in different places, I can import data into my data layer. Let's say, oh no, I can't. I can. Okay. So without going further, I mean, this is, I have gone to the next step where I have, we have here, today I created diners, cafes, bars, restaurants. That is 4 data layers. Now, from these 4, I combine all 4 into to this layer, food and drinks, and utilize the additional features that are available in your database, that is subtypes and domains. in order to simplify some of these multiple files so we can group them into one. Now I will cover that in detail next week. So up to here, let's try to work with these 4 files that we have, and in order for me to see that you got the idea or if you are making mistakes, I want one of you to share the screen and start your ArcMap, and you should have a decent internet connection also, because you should be able to get the Google image. Therefore, you should have access to Google image from your ArcMap. Someone with good internet and ArcMap, working copy of ArcMap, can I get a volunteer who would be able to do this? Let me find out from top to bottom. We have Philopitia. Hello, Philopitia. Has he gone somewhere after turning on? Let me see if I have why. Hello. Philopitia is missing. Okay, I go to the next person. Chintana?
So still I have not installed ArcMap.
What is the reason?
My hard disk is not have enough space, so I attach a SSD for the computer.
Can you install on SSD?
Yes.
Right. You might have to install your software in C.
Yes.
Oh, what is the reason for not installing it? Don't you have a copy?
Yes, sir.
You should
the
have
main thing is my hard disk is not enough for the installing. So
what is the memory capacity of your hard disk?
1 to 8. So I installed a SSD card last week. So I have to install.
You have SSD card internally stored
last week, yes.
Last week. How much memory does it have?
256.
256. Okay, that's enough.
Yeah.
So why don't you install immediately the software?
I couldn't find it.
It is available when you come to when you came to the lab. You could have asked for it.
Yes, sir. We asked last week, but I didn't bring the laptop.
Did you receive the licenses?
No, sir.
But did somebody start the practical classes?
Yes, we did in the labs, the desktop machines. When we asked for the license, madam told that first install the software and then we can take the license. For ERDAS, we have the crack, but ArcMap still.
Does anybody have ArcGIS software? The others? No, you need to individually communicate because you are at different places. You don't wait until other person speaks. This is unnecessary time wasting. Chintana, are you there?
Yes, sir.
Do you have software installed?
Sir, before I talk to you, sir.
You
Just now, yeah.
There was somebody else earlier has disappeared. Tuminder?
Yes, sir.
Do you have software installed?
Still not, sir.
Veer Surya? Veer Surya?
Sir,
Do you have software?
still I couldn't find the software, sir.
Bimsara? Dhammika?
Because I still couldn't find
Dhammika?
the software.
The Tarangika? Tarangika?
No, sir, I still couldn't find software.
Nadi?
Yes, sir.
You have?
Yes, sir.
Okay. Your internet connection is also decent?
Okay, sir.
Okay. Can you start? I will let you share the screen. Okay, can you share? Okay. Stop sharing. I think you can share the screen now.
Okay, sir. It says host disabled participant screen sharing.
Yeah. Share screen. Check if it is okay now. Okay, now what you can do now is to create a geodatabase. So in order to do that, to create a geodatabase and also to create the feature classes, feature data sets, you have to work with the catalog. Okay, go to a folder where you have create a folder, then you will be able to you can rename it. Right, you right click on that. See if you can go inside. Say disconnect folder, there's some problem there. So this is going to be your geodatabase. This is your new geodatabase. In that, this is a folder. It's like a folder. It is in geodatabase jargon, we call it feature data set. So you can come up with a name, maybe diners or restaurants or some such thing. Okay, the 4 layers that you have to create is diners, cafes, restaurants, bars and lounges. So first one is diners, has 3 attributes. Diners. Alias you don't need. Feature type point. Okay, next. Next. Right, you need 3 attributes. Name, rating, 2 attributes, name and rating. Name. Shape field, you can't do anything. Change name, N to name. text 50 characters. If you don't need 50 characters, reduce it to whatever number. Maybe 30 characters in the box below. Not short integer, it's text. Name rank, I think. Rating, sorry. Rating is short integer. Right. Second layer is cafes. Name, rating, those two would be enough. Cafes, diners, restaurants. No, you can't use that. You have, which one is this? Restaurant? Just type restaurant. Name and rating. Rating is short integer. Next one is bars underscore and lounges underscore lounge. Name and rating. Okay. Now click on the plus button, the down arrow next to it. Select the second one, top. Yeah. You can use the place most familiar to you, the town most familiar to you. And there you will be able to basically find these locations, or even arbitrary locations would be okay for the sake of this exercise. You have to digitize these locations individually. So bars and lounges first, and then restaurants and so on. But before that, you select a town. Usually in a town area, you have all these things. And simply digitize 4 or 5 places in the town for each of these things. Okay. We can define the domains for the domain for the ratings. Shall we do that first? For the restaurants, cafes, and bars and lounges, we can basically define rating. First, you have to do it for the geodatabase. At the geodatabase level, right click, properties. Right, click on domains, type a name. Name of the domain. You can say something like you can use the term rating. Rating by diners. Rating, full name, rating by diners is the second description. Right, okay. That is the name of the domain. Go to the next box below. You have to click on the rating. Yeah, okay. Field type, short integer. Okay, short integer. Range, domain type, range. Change it to coded value. Coded values, right? We don't have default, split, forget about those. Now you have to type a code and a description. Now the codes I will read out, you can type them. The code numeric value 1, poor. Poor. 2, fair. 3, average. 4, good. 5, excellent. Right, okay. Do the same for restaurants and the restaurants. You have to click properties. Okay, properties, domain. Wait a minute. Okay, you have to assign the domain. Okay, right click. Right click the right click the feature class. Yeah. Properties. Wait a minute. Sorry, select features. Sorry, select the bars and lounges. Right click. Properties. Click on fields. Right, okay. Right. Rating, yeah. Okay, click on the rating. Domain. Click on the box. Right, rating. Right, okay. Apply. Do the same for the other two layers. Right, okay. Now, select a town that you are familiar with. You have to enlarge that area. Use the, you can use the zoom in, the plus sign, and then draw a box around the area. Okay, okay. At this stage, I mean, you don't have to be exact locations, just arbitrary locations. Okay, take each layer at a time, each shapefile, feature class at a time, here in ArcMap. And editor, go to editor, start edit. Okay, so I mean, all of the data layers are editable now. Bars and lounges, digitize 3 points. Now you can remove the catalog now. Now in editor toolbar, the last tool set, last one. Right, click on that. Right, now this is the digitizing tool. You can select bars. And one other thing, at the bottom, you have this vertical line on the right hand side, vertical line at the bottom of this top box. No, above that. Go to the next frame. No. Can you move cursor slowly upward from the bottom? Okay. Go up a little bit. No, just cursor. Right, okay. Go to right. In that box, the first one has the layer names. And below that, there are 2 icons. Just below that, immediately below that, 2 icons, not that, above that. Right, in that row, there are 2 icons on the right hand side. One of them is the vertical line up and down. So your cursor is at the wrong place. Go up. Not there, okay. Go to the bottom of that box. No, there are several boxes. The listing box, there is a blank white area. Okay, right, stay there. And look at the next row. Next row, in the gray area, there is a horizontal line. At the end of that row, there are 2 buttons. Next one. Right, click on that. Okay, now you can resize your box, reduce the height. The height of the box can be reduced. Not that. You know, this entire box, there is a large area without any information. No, cancel that. Okay, go to the bottom of this where you are. Go to the border. Border at the bottom. No, the other one. Horizontal border. Below. Bottom. Okay, see if you can get the resize icon. No. Don't click on anything. This is a box. Consider the entire thing is a box. You can resize this box because your box is covering the entire area. So you can resize it horizontally as well as vertically. then reduce the horizontal length. Right, okay, that's enough. You slide it there. Now with the point tool, digitize 3 points at 3 different places. Okay, if you have not digitized anything yet, let me okay, near the editor, next to the editor, there is a arrowhead. Next to the editor, yeah, click on the arrowhead. Right, once, click on the arrowhead, that's all. Yes, it's a tool. Now, bring that tool down to the map area, image area. Right click anywhere. Attributes. So this is the attribute box. Okay, this is the attribute box. You can resize it. Reduce the bottom side. Okay, there won't be anything until you digitize a point. You digitize a point somewhere for bars and lounges. You have to select bars and, okay, you have selected bars and lounges, right? Click somewhere. Okay, now go to the, you see that you have a lot of things in the text box. Now click on rating. You get a down arrow. Okay, click on that. Select one of those options. Okay, fair. Okay, now you can type some arbitrary name. This is a bar and lounge. Maybe Queens. It is. Okay, Queens Hotel or something. The name can be without any, you don't need hyphen. Space is allowed when for the data that you enter. Right. One other thing I want you to do, go back to the where the data layers are, table of contents. In that, click on the point. Double click on it. Okay, select something visible in this background. You okay, whatever color you want. Okay. don't see it. Maybe digitize a point near Queen's Hotel. You can actually move this text box, attribute box, place it below the tool set. And Queen's Hotel is next to towards the end of the hotel. There is a long building along the parallel to the road. That is the Candy. So digitize another point. Yeah. Wait a minute. Point is not visible. I think it's click on the bars. The up. Yeah. And then select the point tool. All right, okay. Now select the rating. Right, okay. Color disappears. I don't know why. What you can do is turn off the image from the table of content, the world imagery, world imagery. Turn off that. Just click, yeah. Right. So there is. Click on the other one also. Turn off the other one also. The world boundaries. Okay. Reduce the zoom. You can actually right click on the bars and lounges and say zoom to layer. Right click, zoom to layer. Okay, click right click on the bars and lounges. Open table, attribute table. Say okay. There's no date was cancel that. Click on restaurants. Check the attribute table. That also doesn't have anything. Cafes. It doesn't have. Okay, click on editor. Stop editing. Yes. Unable to save edit. Error. Stop in an edit session with save edit pass long. Yes. Unable to save edit. Error stopping an edit session with save edit. Say okay. I think you might have to restart. Anyway, so we saw how to digitize. You can try out restaurants feature class and see if 3 points anywhere. I mean, you don't have to worry about the satellite image at this stage. Just digitize 2 or 3 points. Even without the world boundaries, because it's the computer is slowing down when you have all this data. Editor, stop edit. No. Okay, just go to the editor again. Save edits. Okay, it looks it is working. Now this is go to the layer, whatever it is, and change the symbol. Okay, that has worked. Click somewhere else, then now the point is there. Okay, so do the same with the others also, just 3 points each. You might have to increase the size. Right. Do the same for the restaurants. Unable to save edits. You don't have this file open somewhere else, no?
Yes, sir. Yes, sir.
I think what you can do is leisurely try this, start a new project and load the data from your database and see if you can if you still get the problem. I can't figure out what it is right away, but it shouldn't be there. But I think you should restart ArcMap, start a fresh project, and make sure these data layers are not open in any other ArcMap project, and digitize. Next time you can probably digitize places you are familiar with in Candy Town or wherever, and enter some values. Next week we will go into subtypes, domains we covered here. We can go into subtypes and relational tables, how to establish relationships with other things. So for today, we stop there, and we meet again. The last class would be next Saturday. And what as exercise, what I want you to do is practice this, all of you, and prepare, since everybody doesn't have software at the moment. The assignment would be a conceptual one. Prepare a schema, database schema, the way I describe them, or in a new way, it doesn't matter, and submit it as the assignment. Okay, so one assignment for this session. Submit that when you have finished, and we will have exam. We can discuss the date for the exam for the this part of the spatial data management course, and that will be the end of this segment. Okay, with that, I stopped here, and we'll see you next week.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.